All right, folks. So here we are. We're up to Chapter 8, Forensic Duplication. We finished Chapter 7 last time, and that should be ready to go. And here it is. Okay. So this is an activity I've mentioned many times. This is the old-fashioned computer forensics, where you try to get an image of the data on the hard drive. And there's a whole bunch of lore to this, dating from the time when this was all you did, and you expected it to be perfect. These days, people have pretty much gotten over that. But anyway, the simple duplication is like you normally do when you're backing up files. You just make a copy of the files, and that's fine if all you want is the active files you're using. But the point of forensic duplication is you copy every bit on the source drive, and that way you can recover deleted files. At least you can when it's a magnetic hard drive. When it's an SSD, you may or may not be able to recover any deleted files. So that's the idea. But anyway, the point of this was to make admissible evidence in court proceedings. You get a complete image of the drive with a hash value, and then everybody can verify that they have an exact copy. And you send, one copy to the prosecution and one to the defense, and they've got exactly the same data. So there shouldn't be much argument over what the data shows. So you want to have a tool that can gather every bit of data off the storage medium, and you would like to be able to do this for things like cell phones and stuff, although often you can't. And then you want to make a forensic duplicate, and you need to handle read errors. A lot of devices have read errors, so when you read something, you don't get the same answer when you read it a second time. And when that happens, there's no way any copy can be perfect. And you just need to know when that happens and record that fact. In that case, the MD5 hash is not going to be any good because another person reading it will not get the same hash. So now here's the one that's pretty entertaining and led to a whole bunch of lore, is reading a drive without making any changes to it. Now, back in the old days of the flat ribbon cable, you could just cut one of the wires. One of the wires was the read wire and one was the write wire, and that's all you had to do. But modern hard drives are much more complicated. And in fact, every time you boot up the machine and it detects a hard drive, it immediately writes on the drive. I wiped out a shared machine one time this way without knowing this. I thought if I installed a new operating system on a separate partition, it wouldn't affect the other operating systems on the machine, but it does. And it writes to the journal and writes notes. So every time you touch a drive, it changes it. So you need to get a write protector, and write protectors are complicated. Here's another fundamental problem, which is not very well known. You cannot read every bit off a modern hard drive or SSD. They have extra blocks that they don't tell you about, and when it detects a read or write error, it silently replaces that block with another block. So that means there are blocks you can't reach in the normal process of reading and writing, and people can hide secret data there. And it also means that there are leftover blocks marked bad that still contain data you can mostly recover. And there's no way to read them or erase them with the normal firmware. The way to get there is to hack the firmware of the drive itself to read, and that is not a normal activity that anybody bothers with. Now, there is a tool called ProDiscover that made a big deal out of the fact that they could read these host-protected areas of the drive, and they tried to market it for forensic scientists this way, and they found that nobody cares. In principle, you could have criminal stuff hidden in the host-protected area. In practice, nobody ever seems to do that. So this feature did not really sell their product too well. But they're right. In principle, you could hide data there. It's just not, in practice, anything anybody much does. So once you get an image, the simplest one is just a complete disk. But you can also have just one partition on the disk or a logical copy of like folders or something. So a complete disk image is the normal one you want. Everything. The boot sector, the partition table, all the partitions, every single bit. This is the image that will let you recover deleted files. And you can just view it in HXD. You can view the raw disk in a hex editor. And when forensics started, like 25 years ago, I remember one of my teachers told me the only tool available was Norton Disk Editor. And this is all you would do, is look at the raw hex data on the disk to find things. And this is how you verify things. By the way, one important thing is you never want to trust your tools too much. All the tools have bugs. Some of them have serious bugs. So you never find anything important, you verify it with another tool, and a good tool is a raw disk editor to make sure that what it found is really there. Anyway, you can then view a partition. So if you view a raw disk, then you'll get this series of zeros, and then you'll get the beginning of an NTFS partition here. If you view a raw disk, if you view a partition, it'll start with the NTFS marker here, or whatever that is, NTFS. That's going to be anyway. There are different ways to view a drive. The raw drive, you see the whole of the physical storage of it all. The partition, you see the partitions that are here, like the drive letters C and D. And those don't from the start of the drive. There's the boot sector at the very start to boot up the operating system. Then there's a table that tells it where the partitions are, and then there's the partitions. And if you are using a machine and you look at my computer at the C drive, you're only seeing this part. You'll never see this part unless you use a special tool. All right, FTK Imager can do it, although as we talked about last time, it's perhaps not the wisest tool to use because it uses more memory than other tools, but it works. So you can acquire the physical drive, or you can acquire the logical drive, which would be the drive letter, like C. And you also get the contents of a folder and other things. Now you can save it in a variety of formats. The simplest is DD. That is just a bit-for-bit copy of the drive. So if you have a 1 terabyte drive, it makes a 1 terabyte file. And that is the simplest. Of course, that means you have to move around a 1 terabyte file, which is big and clumsy. So people usually prefer to use these other formats that compress it. So, all right. And they're all mathematically identical. All these are is just zip versions of the DD. So you can unzip them and get back to the original drive. So if a subject tries to hide data by deleting files or partitions, reformatting, or so on, none of these will protect the data from a whole disk image. All that will happen is, say, if you reinstall the OS, it will write on top of some of the files, and that data is gone, but the data you didn't write on top of is still there. And the operating system is not a large portion of the drive usually, so that means most of the data is still there. So there's a host-protected area, and it's something called the device configuration overlay, and these are used for recovery utilities. They're not available to the user to store data. Now, like I say, in principle, you could hide secrets there, but it would be difficult, and nobody does very often. So active data is all that normal people use. These are files and folders that are in use. They haven't been deleted yet. This is what you normally use to use a computer. Unallocated space is leftover, space between that might have leftover data from deleted files. And there's also file slack. When you read and write to the drive, you write in units of a block, which is typically 4 kilobytes. So if your file is a little bit bigger than 4 kilobytes, it will use 2 blocks, and there will be some stuff left over in the last few kilobytes of the last block. Those are called file slack. These are almost always useless. You won't even have a complete file. You won't have a file header. You'll have a few hundred bytes out of the middle of a file left over. Normally that's useless, but if it was a text file, it might be readable, and it might possibly contain something useful like a password or something, but it doesn't have an owner or a timestamp, so you really don't know who put it there or how long it's been there, and that can be pretty confusing. So usually the file slack is useless, but the forensic tools will recover it for whatever good it is. So, all right, you might image just one partition of a drive instead of the whole thing. This is not a normal thing to do. The only typical reason you would do this is because you have a shared drive and different users have different partitions, and you only have a court order allowing you to take the data of one user. And that's often the case that there's a legal requirement. So, all right, and then you'll be able to cover deleted files on that partition, but you wouldn't have other areas of the drive. So a logical image is what you normally do just to copy files. A simple copy of the files and folders. You don't get any of the unused blocks. You just get the active files. This is what a normal backup is. And, of course, that's useful data. Anything you do is real data. Just record what you did and be prepared to explain why you didn't do a physical image. Because it's the normal thing, and here you are doing something non-standard, and so there may be questions about why you did it this way. It could be you made a mistake. That's embarrassing and not so good. It would more likely be there's some good reason to do it this way, in which case you'll want to have a record of what that good reason is. So a logical image, when you're only allowed to get certain files, like from a network attached storage, a shared device, or you might have files from a business critical thing that cannot be taken offline for duplication, and you can't perform a live image. There is a time when you had to stop using files to copy them, but that has been over for at least 10 years since Vista. There's a way to copy files while they're in use. By the way, that way, what you do if you do that, they call it a smear, because the file might change while you're reading it. So you get one end of it will be at one time, and the other end of it will be at a different time. So the image is not all taken at a fixed time. And like I said, that's why the old rule was kick out the plug, turn off the power, then image the drive while nothing is changing. But if you're imaging a live system, things might be changing while you're imaging it. And that's another reason why your copy might not be all that perfect. Let me check and see if there's comments in the Twitch. I don't see the slides. Oh, this is bad. Okay, let me see what's going on. It says it's streaming. Let me stop and restart it. All right, let me stop.